yet again, we will have a talk about UI in Bevy. And I'm super excited about this one because I personally think the project where this is coming from, his own UI framework, is super exciting. And as we all know, the more we are building Bevy UI out, the more I think it is beneficial to all of us to have a diversity of input of all the different approaches of UI. So let's welcome Ko on stage. Hey, welcome.
Hi, everyone.
Here are your slides, and I can't wait to know how we finally reach escape velocity with Bevy UI. Take it away, Ko.
All right, so yep, I'll be talking about Bevy UI today. Let's see. So I think most people who use Bevy know that raw Bevy UI is tedious and verbose. This is a long-standing problem. And so for a long time, I have been searching for my own personal escape velocity in developing Bevy projects that include UI. So in this search, I've really come to understand that there's no single panacea that will solve this problem. Instead, it's a long incremental process of shaving off excess weight or streamlining the rocket, so to speak. And at a certain point, once you have accumulated enough improvements, that's when you cross the line into escape velocity. And that's, I think, personally, in my personal experience, that's what I've achieved with my project. So, and I'd like to share that with you guys. So here's the situation with Bevy UI, generally speaking. Writing UI directly in Rust has been improving over time. So we've seen a lot of innovation and experimentation in this area. So Sickle UI, I can't believe it's not BSN. Dreamer Talons projects, Bevy Deoxys, and so on have all been pushing the envelope of how easy can you make it to write the UI within Rust itself. However, I think many people recognize that there's a fundamental problem that in Rust UI cannot solve, and that's the curse of the recompile. The recompile loop to make changes and adjust things when you're doing UI is extremely painful, even if it's only 1 or 2 seconds gap. It just disrupts your workflow, and it's importantly not editor compatible to have your UI only in Rust. So my solution that I developed in my crate is not surprisingly asset-oriented UI. And so I'll talk about BSN in the next slide. So the project I developed had these design goals. I wanted it to be painless hand authoring, zero pain, as much as imaginably possible. I wanted minimally destructive hot reloading, which means when you hot reload your asset with the UI in it, it does not destroy the scenes you've spawned. It only destroys things that must be destroyed. So if you remove a node, it will destroy the node. It'll despawn the entity. But if you change something on a scene node, then it will only mutate the existing entity. I also want the specification in the asset to not just be components, but to include arbitrary entity mutations. So things that look like entity commands. Within the assets, I wanted to be able to reuse data and patterns to support, to reduce duplication and to enable asset-driven widgets. I also wanted the whole framework that extracts the assets to be compatible with an editor that allows simultaneous hand authoring of files. So you can go back and forth. You could go back and forth between an editor and hand authoring the file. And since the file is painless to hand author, this back and forth should be natural. And so to bring it all together into the world of Rust, all scene logic needs to be easily added at runtime. So you spawn a scene and then you add logic to the scene that you've just constructed. And so to do that, you need to be able to dig into the scene to get at the nodes where you need to add logic. And so I'd like to honorably mention Bevy UI crate, which is a pseudo HTML UI that has some similar design goals to me. And that crate actually really inspired me to make some recent major improvements to my crate. All right, so now we can think about, what about BSN? So why would I bother going through this huge amount of work when we've got BSN on the horizon? So there are a few things that really stick in my mind. One is that there are different design goals. So my design goals and the goals of BSN are not the same, and so that's a big motivator for me. So BSN appears, as far as I can tell, is components only. Everything in the BSN scenes is going to be components, whereas in my design goal is to include entity command like things within the scene structure. Hot reloading BSN, it sounds like the plan is to just wipe out whatever exists and then respawn a new scene. This has editor performance implications because if you are rapidly changing some value within a scene, and to reapply a scene, you need to destroy the scene and reconstruct it. It might not be feasible actually to rapidly change values within the editor. That remains to be seen, of course. And also, it's really not clear at all how scene logic would be integrated with the BSN. There's been some talk about baking in the scene logic, so trying to add components that represent scene logic. And I find this, it's too entangled, I think, I feel like. We're also aiming at different feature sets. So as far from what I've seen so far, BSN is primarily a scene format that creates scenes, but the asset format I constructed and I'm going to be showing you guys today includes a lot more than just scenes. It includes commands and constants, and there's more stuff that has yet to be developed. Also, BSN is not available yet, and if it was available, maybe I would not have built this crate, but I want to find escape velocity for my own personal projects, which are, I mean, within the time horizon available. This crate was the best option. And also, finally, building cool tech is fun, and I had a lot of fun building this crate. So that makes it all worth it. All right, so here's a little introduction to Cob, the Cobweb asset format, which is found in the Bevy Cobweb UI crate. And so as you can see, the hot reloading works just great. And adding stuff is painless. I sped it up, but in the course of about 2.5 minutes of real typing, you can create a very ugly button, as you will see soon. And there it is, my ugly button. All right. So in developing this asset format, there are some key ergonomic wins. So if we go back to the slide and play a little bit, we can see that there is no structure around. So this is a scene. This is a scene here, but there's no braces for the structure. So scenes are only use indents to identify the scene layers. There's also no commas between fields in a struct. I simply shaved off all of the unnecessary things. Also, I added new type collapsing. So within the asset, when you have some complex structure, so you have an enum that it's a new type enum that wraps some struct, and when you can collapse this so that you only need to write the enum variant and the the container. I also included built-in types so that you only, so since this is UI focused, we have val. Instead of writing px, the px enum, you just write px like this. I think that's it's really helpful to have that. And similarly, I added built-in hex colors for sRGPA. And all of these wins, these are all small increments that build toward a faster rocket ship, I guess. All right, so here's a little demo of hot reloading scenes. And so this hot reloading is non-destructive. So when I rearrange the nodes, it's rearranging the actual children of this parent node. So when I take the node out, it despawns it, and when I put a node back in, it spawns a new node in the correct, or a new entity in the correct position with the right scene content. So like I said, the hot reloading is minimally destructive. But to accomplish this requires certain restrictions, because if you're, as I said before, I want these things here, these loadables, to be not just components, but to be like entity commands, or I call them instructions. So they have a mutable reference to world when they're applied, which means they can have arbitrary side effects. And so to support that, when you're mutating, when you're doing some hot reloaded change to an entity, you need to be careful that the side effects of any loadables that you previously had in there are handled appropriately. And so, yeah, the problems are, and then the loadable list, it might be a cumulative process. So since they're not single components but mutations, the full set of mutations might cumulatively result in something that is different if you reorder the loadables. So to solve this, my solution was, whenever a loadable is hot reloaded to be changed or to be removed completely, you revert the loadable. So for components, this just means removing the component. But for instructions, this means you have to implement a function that will undo any side effects of that loadable. So this is some cognitive overhead, I suppose, that is like as an alternative to the cognitive overhead of doing a primarily component-based approach where you have to use systems or hooks to manage everything. And then so after you've done reversions on a hot reload, then you reapply all of the loadables onto the node. And that way the cumulative effect that you end up with after reverting and then reapplying is the correct final node state, ideally, unless you mess it up. All right, so we can move on to the next feature of the asset format. So this is the manifest section. So here we can see, oops. Here we can see that the file loaded into the app is main.cob, so this file here. And the scene loaded is loaded from the my scenes file. But my scenes is not here. So the manifest brings in this other file, scene.cob, over here, and gives it a manifest key, my scenes. So this is the manifest key here, is tied to this manifest entry in the main cob file. Oops, damn it. All right. And then when you hot reload the transitively pulled in file, it works as expected. All right. So manifests allow you to load cob files transitively, recursively, whatever. And they give you manifest keys so that when you load a scene, you can specify the manifest key instead of the file path. And manifest keys are also used for imports, which I'll get to in a later slide. So the next little feature is commands. Let's see here. All right, so we can see down in the command line that it is printing out this command because the command itself is defined as just a print statement. It prints itself. And the only other thing to note here is that you have to register the type that you're going to load. But other than that, it's quite simple. You derive reflect, default, and partial eq, and then implement command, and then you have a command that will automatically run during startup once it's been extracted. So all commands are applied during startup. So it's not in the startup system, but it's in the very beginning of your app while extracting things. All commands are globally ordered by manifests. And this was a recent incremental progress I made in the development of this project. Globally ordering means that you can have commands that depend on other commands. So you could load an asset in one command that other commands later on reference. So you load this asset into some asset map that caches handles, and then later commands can safely access that map to pull in to pull out the handle, and it'll be the right handle. So when doing hot reloading of commands, we make sure to always wait for any pending files to ensure that all side effects of a hot reload, which could affect multiple files, is respected, and that the final global order of modified commands is changed. So if you changed some constant, as we'll see, that is used by multiple commands, when that constant change is hot reloaded, the backend system will wait until everything is done propagating to apply the modified or the affected commands that depend on that constant. And then similarly, scenes will wait until all commands have been applied after a hot reload to ensure that if a scene depends on some command, like if a scene references some asset that is loaded by a command, then the scene will properly wait and reload after the asset has been refreshed. All right, so we can look at constants now. These are very handy. So I pasted in the def section, definitions. I defined a constant green. It does what you expect. Here it goes. All right. So constants allow data reuse, and right now I built in assets, so embedded files in the crate that define all of Bevy's built-in colors. So we've got the Tailwind, CSS, Basic. I think there's another one. All those constants can be used from within COB files just by importing the built-in file. All right, so here's a highlight of what I was talking about before with how a constant can be used to reduce duplication of this PNG location, this file location, and it ties together multiple loadables, so command loadables or scene loadables that depend on the same string. All right, so we can talk about now importing, which lets you bring in definitions from other files. So this is separate from the manifest. The manifest says load this file, but the import says bring in definitions from this file. So we use the manifest key for imports. So here we're importing the Tailwind built-in file, giving it an alias, and then we can access the constants from within that file like this, and there we go. It changes the colors, and that was all hot reloaded. So very handy for accessing constants defined elsewhere. All right, so right, I've mentioned this before, but loadables are all of the blue items in the scene. So we got, these are all loadables here. Each one is a loadable. So command loadables and scene loadables are implemented similarly, but command loadables, of course, implement command. And scene loadables, there's three types. There's regular Bevy components. There's reactive components from my other library, Bevy Cobweb, which I'll note is a fairly minimal dependency within this crate. The interfaces with Bevy Cobweb are fairly minimal, if that concerns anyone. And the final loadable is the instruction, and the instruction is where is a trait that you implement to get the entity command like mutability. And sometimes you actually implement instruction for components. If, for example, you want the component to be animatable, then you have to implement instruction, because instruction is a type bound on the animation stuff that I have. Here's an example instruction. So we have to apply the instruction, and then we have to be able to revert the instruction whenever it's hot reloaded. And then finally, you have to register the loadable with what kind of loadable it is. So this example is printing to the console. We can see saying hello, and it said goodbye before when let's see, it said goodbye when I deleted it, because it had to be reverted. So I deleted it and then it said goodbye. Okay, so this is a screenshot here of, let's say, so we talked about a lot about what goes on inside the cob files, but what if you went to add logic to your scene, that logic that ties in multiple nodes within your scene tree? And so what my solution for this was heavily inspired by the Sickle UI builder pattern. So we create a UI builder with the UI root extension, and then we load the scene and edit the scene. So we load the scene at the main cob scene with the root scene we pull out. So writing this, it spawns the scene. And then, so the scene is spawned once we're inside this callback here. But the L here is a loaded scene helper that gives access to the nodes of the spawn scene. Once we exit this, the loaded scene will clean up all the artifacts from the scene, because at least in not when you're in a production build, you don't need any of the cached scene structure. But anyway, so once you've loaded the scene, you can edit the scene. And so here I'm editing a sub node within the scene. So I tell it the node name, which is as a child of the parent, and then that gives me another callback where I can do things like insert Bevy Cobweb reactive components. I can call onPressed using an extension method from my crate that uses Bevy Cobweb under the hood for reactivity. And so this function here, this system will run whenever this node is pressed. And then similarly, you can simply get a node, and that makes it a little easier you can directly mutate it, but you only do this when you don't need to introspect even further into the tree. All right. So this is an example in the repo, or the repository. All right, so finally we get to the bonus slide. I'm very pleased to show you guys the bonus slide. I finished it last night. All right, so this is a little editor I built for cob files. And as you can see, when you save in the editor, it saves to the file. When you manually edit the file, it's reflected in the editor. And when you you can change values within the editor, and they're reflected in the spawned scenes in the app immediately. And so this was a long design process to get this to work, but I'm very, very pleased with it. All right, that's the end of my talk here. The crate is Bevy Cobweb UI. Yesterday I published a version 0.5.1 RC.3. And you can also find the crate in the Bevy Engine Discord under Ecosystem Crates.
Awesome, Carl. My God, what a microbe moment, like the second one already in this meetup. Just for the last minute, I wait until I show my editor. Thank you so much, Carl. This is amazing. Pretty cool. So yeah, we have a bunch of questions. For example, me included, I was wondering, as well as others, how did you get syntax highlighting for your own file format in your editor?
Well, all of the IDEs have some method of writing syntax, so I wrote syntax files. It's very painful, but it gives you what you want if you put enough time in. So there's syntax highlighting for VS Code, Vim, and Sublime Text. Although
Nice.
The Vim one is it needs someone to like redo it because it sucks.
Okay, well, to anyone watching and using Vim, this is a great way to start contributing. So, how do you handle development versus production UI? I think you mentioned it in your talk that this is something that you would distinguish. But the question is hot reloading development only? And are the options to compile COP, or are there options to compile COP into a production-ready format?
Yep. So there's the crate has a dev feature which gives you hot reloading, and then there's an additional feature which gives you the editor. And so in production builds, you just don't have those features, and it compiles out tons and tons of backend stuff that deals with hot reloading.
Yeah, makes sense.
It's
But the
kind of spaghetti, honestly, because you got all these configs in there, but
Yeah, of course. But is the format, is there going to be any difference to the format itself, or is it just the same file format that's going to
the
be
file
shipped?
format stays the same. It's just in
Yeah.
how there's a lot of caching that you need to do to get the non-destructive hot reloading. Like for example, you cache all of the entity subscriptions. So all the entities that load something subscribe to a specific scene node. And so you cache those when you're hot reloading, but you don't need that when you're in production.
Yeah, yeah, makes sense. And oh yeah, I guess you mentioned it in the beginning. What recent changes did you make, inspired by Bevy UI?
Oui.
I guess that's how
So,
you'd call it.
so this cob format used to be all JSON, and
Oh,
that was painful, but it was better than raw Bevy UI. It was an increment over Bevy UI, but it was painful. And so when I
hmm.
saw Bevy Hui, I was like, dang, that looks nice. I want to do that too.
Yeah, yeah. Yeah, I mean that's now that you presented it like that, I didn't even think that it might have been JSON before. Makes ton of sense. Yeah. Okay. And what's the most complex UI you built on top of this so far?
That would
And
be
can you
the
show it, of course?
editor. That would be the editor. So this guy here, I built this. It took me, well, like it, setting aside all of the logic for the editor. This was only a couple days, a few days, maybe 3 or 4 days, and part of that was building this little widget here. Um, so this is the most complex UI. You can actually here. I show briefly the widget. So this is the editor widget, which is implemented in this demo example. So this is on the repo editor demo down here. Oops.
So this is like a text editor for the COP file itself,
No,
or
this
what
is
is it?
the Cobb editor is it gives you, it lets you put widgets in there. You stick a widget in, and then it can edit the value within that Cobb file representation.
Ah, okay.
And so this is the extracted Cobb file for the editor extension file. I don't know why it's not showing up down here.
Hmm.
But so this was modestly complex. It was like a 1 day, 1 or 2 days of work. So yeah, that's the complexity level.
Yeah. Okay. That's so cool. Um, I think I would like us to move on to our panel conversation. I'm so happy for your presentation, Ko. I think there's a few questions left, but I would then mix it with the panel and hear everyone's opinion on your work there as well. So yeah, big hands again from chat to you. Thank you so much for presenting your work here and obviously for working on it. And thank you.